use algebra to solve the equation between negative 360 and 0. So our domain is in degrees. So this really is starting off pretty much a grade 11 question. We have like terms. Are you okay that if I put my numbers on one side and sign on the other side, visually can you see that the 5 and the 7 could combine to get 2? And the 2 sine x and the 4 sine x could combine to get 2 sine x, and getting sine x by itself we get sine x equal to 1. Axes family. So axes family, I wouldn't even write a reference angle down, I'd just go right to my answers. When is sine x equal to 1? Someone just say an answer. When is sine x equal to 1? Is your y coordinate at?
Pi over 2.
Pi over 2. Perfect. I wanted someone to do that, okay? Because I want to point out something right now. Did you know you answered in radians instead of degrees? Which is good, because you are now, like, your brain is now doing advanced math. Because thinking in radians, all advanced math thinks in radians. But before this year, you'd been like, oh no, degrees is where I'm at. Okay? This question also, you're going to be very typical. You're going to be getting into a rhythm. You probably would answer in radians because you do that more often, right? But this question, we have to check and we have to say, no, it's degrees. So I'm going to put a line through the radians and I'm going to write degrees. 90 degrees. Which is still not the right answer. Why? 90 degrees is a right answer to that question, but isn't the right answer to this question. Because this question, the domain was, I'm going to highlight it, because this is exactly what's going to happen to you. You're going to go radians, but at some moment, we always want to reread the question. In particular, you're going to want to double check the domain. The textbook is notorious for giving you all sorts of weird domains. Exam is pretty typical between 0 and 360 and 0 and 2 pi, but sometimes they switch it up as well. This one's between negative 360 and 0. It's going in the negative direction. We want, right, again, there's our answer, right, at that blue dot. But 0 to negative 360 would be going around this direction instead of position, so it should be 9 degrees. Attempt number 3, what should it be?
Negative 270.
Negative 270 degrees. I don't mind that you got pi over 2 and stroke it out, and then you get 90 degrees and write a line through that one. I actually prefer seeing that you did that. That's good thinking, right? That's how you would naturally think about it, and then you would get to, oh, my domain is from 0 to negative 360, so my answer is negative 270 degrees. Okay. And then the question says, we also want you to write the general solution. General solution says, first, solve between 0 and 2 pi. Except in this question, what should we do? Because it's degrees, we should first solve between 0 and 360. You did that. You got 90, right? We also got negative 270. Then, whatever answer you get, so I'm going to write x equals 90 degrees. We add 2k pi, well, that's radians. What would we do in degrees? 360 degrees times k, where k is an integer. That's the general solution. But if you look at the answer guide in the textbook wrote this one. Is it wrong? No. Does it make sense that if This statement writes everything coterminal with 90. And this statement writes everything coterminal with negative 270. And negative 270 and 90 are at the same place. It really doesn't matter which one you start with. Me personally, I like the 0 to 360 or 0 to 2 pi. I like thinking in the first time positive round because that is where we're normally thinking. So I like the 90-degree one better, right? You want to make my life miserable on the exam? You can, right? You can like, oh, will Mr. JR figure it out? You could do this. Find some random coterminal one way far away. That would be right too. Be like, haha, I'd have to make Mr. JR think. And I'd be like, I don't want to think. I'll just mark it wrong and then you have to come and prove it to me afterwards that it's actually coterminal. No, I wouldn't. I could do that, right? Not recommended though, right? On your provincial exam, you're not, lately, I've been marking provincial exams for my classes. Okay, in the past, sometimes they get different people to mark different parts of different exams. So, you don't want to be like, ooh, I want to challenge my marker on the provincial exam to see if they really know what they're doing. Not a good idea, because if they don't know what they're doing, they'll just give you no marks. Which could be a little bit of a problem. Okay, part B. Here, I'm going to just move the page. Part B says, use algebra to determine the general solution for cos 3x equals negative 1. This question asked for general solution, and they also asked for the solution from negative 2 pi. Does it include 0? No. Oh my goodness. Perfect. Let's take that little. They asked for these two things. Do you see that this is a multi-revolution question? Okay. Multi-revolution questions, we solve between 0 and 2 pi. And then, we write our domain between 0 and 2 pi for 3x, solve for that between 0 and 2 pi, and then we could do the general solution after that. Okay, we'll do that the same here. So for cos 3x equals negative 1. So many times it's going to be easier if we first think between 0 and 2 pi and then do everything after that according to the domain that they're asking.
This question says over the set of real numbers. Does that change anything? Or is
No.
that just to make it feel more complicated?
Like the general solution means over all numbers. Like general solution means this. So they're saying they're being redundant.
Okay.
They're saying, state the general solution, find all the answers over the real numbers. The domain is XER would be me saying the same thing 3 different ways, but they're just trying to clarify if someone didn't remember what general solution meant.
Okay.
A very good strategy, and it's not always the strategy I'll even put an equal sign in there. I don't care. It's, our brains are naturally going to solve things once around the circle in the positive direction. If you have all your answers once around the circle in the positive direction, you're going to be able to do general solution or any other domain easily. So it's a good strategy to first solve between 0 and 2 pi. If I was doing that, well, what do I do in a multi-revolution question? Step 1 in a multi-revolution question is I rewrite my domain for 3x. If 1x was once around the circle, then 3x's would be 3 times around the circle from 0 to 6 pi. Then I would solve for 3x. Well, minus 1 is on your pi plate. It's your axes family. The first time around, that happens at pi. The second time around would be 3 pi. And the third time around would be 5 pi. So I could solve for x by dividing each of these by 3. And that's once around the circle. So I'm just making a note again. I know I said it at the beginning. We're first solving between 0 and 2 pi. We did that. Those are our solutions between 0 and 2 pi. If you have your solutions between 0 and 2 pi, part I of this question asks for the general solution. Well, my general solution is easy to write. I just take my answers from 0 to 2 pi, add 2k pi to each of them. General solution done. Everything coterminal with those ones will be all of the answers that exist. Part 2 of this question asks for the solutions between negative 2 pi and 0. Okay. What's coterminal with negative pi over 3? Right? Here's negative pi, here's pi over 3, sorry. Here's pi over 3 in quadrant 1. If I went in the negative direction, do you see that that would be negative 5 pi over 3? Here's pi. In the negative direction, what's coterminal? Negative pi. And here's 5 pi over 3 in the negative direction.
Excuse the interruption, but all students going on the zoo field trip, please go to the cafeteria right now. That's all students going on the zoo field trip. Please go to the cafeteria right now. Thank you.
And now, if we have our solutions between 0 and 2 pi, then we can work with our general solution and our actual solution easier. And I find this is probably the easiest way to think about most questions, because you're used to solving between 0 and 2 pi. Most of your questions solve that way. So doing that first gives you a basis from where you can solve other things. Is it always the fastest? No. I can sometimes I can think about my techniques in different orders, and I can get the same answer, sometimes even more elegant, by doing it in different ways. So I'll give you an example of a more elegant way. Solve for x 10 of x, I'll make it 10 of 5x equals negative root 3 over 3. General solution. Do you see this is a multi-revolution question because I have the 5x? But I'm going to, and you see it's also a general solution question. And I'm going to solve this one a little bit differently. Okay? Multi-revolution says, write out your domain for 0 to 2 pi, change it for your domain for 5x. You would get 10 answers going 5 times around. Does it make sense? You get 2 answers going once around. If you went 5 times around, you would get 10 answers between 0 and 2 pi. And then you would have to write out all 10 of those answers plus 2k pi. That is the method we've generally used for now. Okay? What I'm going to do is I'm going to do this one slightly different and then slightly more elegant and see if it makes sense. First, I am just going to write out the general solution for 5x. Root 3 over 3 is part of your pi over 6 family. You would look in quadrant 2 and quadrant 3. Quadrant 4, because it's negative. If this was just a theta, our question would be done, right? Because those are my answers from 0 to 2 pi for theta. And I wrote my general solution. But it's not a theta, it's a 5x instead. But if I started with this idea first, some of you are going to like this because if it's a general solution and a multi-revolution together, this is quicker and more elegant. How would I get x by itself? I would have to divide this by 5. Can you see dividing this one by 5 would give me pi over 6. And if I divided this by 5, I'd get plus 2k pi over 5. The second one, if I divide it by 5, multiplying by 1/5, will give me 11 pi over 30. So if you have multi-revolution and general solution together, you can either think of doing the multi-revolution strategy first, then general solution, or you can think of doing general solution strategy first, then multi-revolution after. Both are fine. This is more elegant in this situation. So I thought I'd show you that as well. On your review, I give the answers if you use this technique or the other technique. Did I give you questions to circle on this one yet? 4, 8, and 9.